Hello friends, SentinalhMC here, and welcome back to our Immersive Engineering tutorial series. In this episode, we're going to take a look at the few additional bits and bobs that might help in managing your electrical grid, and hopefully clear up a little bit of confusion that may have resulted from the last episode talking about the various voltages of power. So, to get started, we're going to be talking about the engineer's voltmeter, the current transformer, the breaker switch, and the redstone breaker. So the engineer's voltmeter is the first and, well, probably second simplest thing, because the breaker switch is pretty simple. Basically, you hold it in your hand, and it allows you to see how much power is stored in various things within your system. So, if we take a look at its crafting recipe, it's simply a copper ingot, 2 treated sticks, and a compass. And if I select it, I just hold it in my hand, and if I aim it at stuff that has power, that power storage will pop up. So this is very useful on mod packs that don't have Wayla, because if you look at the bottom right, Wayla is just showing me everything. But if I didn't have that, I would use the engineer's voltmeter, and as you can see, the little needle actually changes. It actually moves around and adjusts itself to let me know, you know, how much power is stored in it compared to the maximum possible. Okay, so over here it's all the way to the right. Over here it's just below the center, and over here it's you know, like, you know, almost full, but not quite. It'll also work on little energy connectors. So that's the engineer's voltmeter. Also, apparently if you hold shift and you right click on a connector and then you do the same on another connector, it's supposed to show you like the amount of power that's passed between them, but I couldn't get that to work in my survival world. On the other hand, the current transformer basically does just that. So what the current transformer does is that you put it in line to a power connection, and it will tell you the average amount of power that has been transferred through that connection in the past 20 ticks. So if we check it out, the current transformer requires 2 copper wire coils, an engineer's voltmeter, 2 hardened clay, and 2 iron ingots. And if we come over here and place it down, it looks just like that. Got a little green light on the back. It's got 2 connection points for power. If we go into the engineer's manual and we check out its description, it will keep track of energy transferred through it, returning an average RF per tick upon right click. Alright, and we'll demonstrate that shortly. The breaker switch, as you may imagine, you can attach 2 of the same type of cable to it, and when you the power will only flow through when it's in its up position. This is a standard knife switch, like the kind that you see in like Frankenstein and other mad scientist movies. It's crafted very simply with a copper ingot, a lever, and 2 hardened clay blocks. Very, very simple. Now the thing about the breaker switch is that you can't hook high voltage wires up to it, because obviously that would be incredibly unsafe. So if you want to use high voltage, you need to use the redstone breaker. The redstone breaker does the exact same thing as the breaker switch, except that you cut off and allow the flow of power by putting a redstone signal into it. And it's crafted with a piece of redstone dust, 4 iron ingots, a redstone repeater, and 2 high voltage wire connectors. Alright, now actually I forgot, the breaker switch also has another functionality. It'll actually output a redstone signal when it's on or when it's off, and you can invert that by smacking with a engineer's hammer. Alright, so that might be useful. I don't know, depending. Now, I want to use the current transformer and the breaker switch and stuff in order to show you, try and demonstrate a bit more clearly the effect of using different voltages of power and why you would want to do so. Because there was a bit of confusion, because you can connect 2 high voltage capacitors together using a low voltage wire, and it won't melt. The power will go between it. It'll just go incredibly slowly. And so there was, you know, some confusion in the comments as to, well, why would you even want to use the higher voltages? Well, let's take a look at it using the current transformer to tell us the full story. So I'm going to place down an empty medium voltage capacitor over here, and I'm going to place down 4 full low voltage capacitors. These are all full of 100,000 RF. This thing over here can store 1 million. So we'll pop connectors on all that stuff, and then we'll run ourselves some wire. We're also going to pop a low voltage connector onto the medium voltage capacitor's input. So now if we go ahead and take some low voltage wire, we can connect our current transformer through our switch. Switch is currently in the off position. And then we want to connect all of these up to the breaker switch. Fortunately, my phone's ringing. I'm the only one here, so I can't get it. So it's no one important. They're just going to have to not talk to us. Okay? Now, you can only connect one wire into this thing, so I can't connect... like... Oop, no. I can't connect, like, all of these. Come on, stupid phone. So if we want to do that, connect all these together, we're going to simulate that by... because you can do this. Connecting... no. Connecting 4 of these capacitors down to a single connection. Because you can put as many of these in here as you want. So imagine this is a whole bunch of power sources we've got scattered around, and then this is one power line that we are connecting it to, so we can run only one power line. Well, if I stick with low voltage and I connect this in here, and then flip the switch on, it's going to start putting power into here. And then if I look at this current transformer, it'll tell me that over the last 20 ticks, an average of 256 RF per tick has traveled through it. Okay? So that's one way of doing it. However, if I cut that wire and we grab ourselves a transformer, and I'm going to need to move this, I think. Grab ourselves a transformer, cut that cable, place a medium voltage connector here, get ourselves some medium voltage wire, plug that in there, and then we'll go ahead and put the breaker switch. I don't know. I guess we'll have to put it, I don't know, we'll see if we can put it here. Grab some low voltage wire, pop that there, pop that there. Okay. Now we have these 4 low voltage capacitors connected together, going through a breaker, going into a transformer, upping it to medium voltage, and then going into a capacitor. If I flip the switch, and then we right click on this, we can see that even though it's the same 4 batteries with the same low voltage connections, the fact that we're transforming into medium voltage has allowed an average of, and it's going to drop down now because one of the batteries is dead. But so we're going to reset this a little bit. But as you can see there, an average of 1024 RF per tick was able to pass through before they ran out. So we'll just go ahead and replace them. Do it again. So now if we look, an average of 1024 RF per tick. So by using a transformer and going up to medium voltage, we're able to pull the power out of these things 4 times as fast as if we just used low voltage wire. That is the benefit of high voltage. So I hope that's gotten some of the confusion out of the way as to how that works and why you would want to do it. Now let's see if we can't get a redstone signal out of this breaker switch. That's not how it works. How does it work? There we go. So as you can see, when the breaker switch is currently on, it's now outputting a redstone signal. However, if I grab my engineer's hammer and I right click on it, it's now set to inverted and it'll output while it's off. And when I turn it on, it'll turn off. So you can use that for controlling your, I don't know. I'm not really sure what I would use that for, but you can totally do it. Redstone signals are always useful, right? Now the redstone breaker. It's basically this exact same thing, only it works for high voltage. So we've got a source of high voltage over here, and we've got a place to put it. So let's just break this, and we will use it. So I'm going to place down the redstone breaker right here in the middle. And then we're going to grab ourselves some high voltage wire. We're going to connect that to the breaker and connect that to the breaker. And as we can see, no power is flowing through here at all. If, however, we place down a line of redstone of some description and then grab ourselves a lever or any other source of redstone signal, boop, now power should be flowing through, but it's currently not. Why is it not doing it? Oh, I'm an idiot. We have both of these on the input. Alright. That is, I'm just probably gonna cut that out. Anyway, now that we've got one of these outputting power, we can see that power is currently going through it. However, if we then use redstone signal... Oh, where's my redstone dust? And that's not going to work because it's up too high. Come on. We can cut the connection. So there we go. We finally got it to work because I'm an idiot. So that is the 4 blocks we're looking at today. Hopefully the current transformer helped you to recognize the usefulness of transforming your current. And the breaker switch, quite useful. And in the next episode, we're going to take a look at some more cool stuff for Immersive Engineering. So I hope you guys are enjoying the series as much as I am. I like Immersive Engineering. It's pretty darn cool. Stay tuned for future episodes. I'm SentinalH, and I'm signing out.